Okay, good afternoon. Today we're going to take a look at the second part of section 6.4, the quadratic formula. We usually like to split this up into two separate sections so that it's not so heavy for you. In any event, let's continue with this discussion of the quadratic formula. A couple of things we're going to be focusing on in this lesson. The first, of course, is the derivation of the quadratic formula. How did we get this negative b plus or minus square root of b squared minus 4ac all over 2a. This is going to be one of your best friends moving forward. It's not going to be a formula you're ever going to be given. You need to memorize this formula in order to survive in grade 11 and grade 12 mathematics, and if you take mathematics at the university level. The only time you'll never use the quadratic formula is if you're taking a statistics course. You probably 99% probability that you won't encounter the quadratic formula. But otherwise, anything past grade 10 math, you're going to need to know the quadratic formula quite well. So let's derive the quadratic formula. The derivation of the quadratic formula follows using the process of completing the square. So here goes. So we'll start with our quadratic formula. So ax squared plus bx plus c equals 0. The only difference from when we last completed the square is that we now have an equation. But the process is exactly the same. We'll start by factoring out a out of the quadratic and the linear term. This becomes b over a times x plus c equals 0. We will take half the coefficient of the linear term, and half of b over a is b over 2a. So this becomes b over 2a. We're going to add its square, and we're going to subtract its square. And close the bracket, plus the c equals 0. Now, some textbooks will move the c over beforehand. I just like to keep everything on the one side until I'm ready to move it over. So these first three terms form a perfect square trinomial, so I'm going to factor that out, and we get this wonderful mess here. And plus c equals 0. And now I'm going to distribute through the a. So I'll have a bracket x plus b over 2a squared. Oh, we left out a squared here. This part here becomes, maybe we won't distribute the a just yet. We'll wait for another step here. This becomes b squared over 4a squared. Convince yourself of that before we go too far, because when we square this b over 2a, we get b squared in the top, and in the denominator we get 2a times 2a, which is 4a squared. So now we're ready to distribute this a and remove those square brackets, and we'll get x plus b over 2a all squared, and then minus b squared over 4a plus c is equal to 0. So again, when I multiply this a by this first this first binomial, the brackets are removed. But when I multiply this a by the second part that's inside those brackets, that denominator changes and becomes simply 4a. At this point, we can clean this up a bit, and we'll find some common denominators over here. Actually, we'll bring everything over to the other side at this point. We'll get b squared over 4a minus c, and we'll clean that right side out by finding common denominators. So we'll get b squared minus 4ac all over 4a. It should be shaping up pretty good. It looks almost like the quadratic formula, but we're not quite there yet. We need to get rid of this a. We're going to divide both sides by a. On the left, it'll disappear, and on the right, we actually get an extra a in the denominator, and it becomes 4a squared. And now we're ready to get rid of this squared. So x plus b over 2a is going to be plus or minus square root of b squared minus 4ac all over 4a squared. And we're practically done at this point because we get x plus b over 2a is equal to, This radical, it can be split up into numerator and denominator, and in the top we get b squared minus 4ac, and in the denominator we get root 4a squared. Now, of course, we have a plus or minus in front of the numerator over here. So x plus b over 2a becomes plus or minus. This numerator cannot be simplified, so we'll just leave that alone. And the denominator, however, can. The square root of 4a squared is simply 2a. And now we bring this term to the other side, and we are finished. There is our quadratic formula. Yay, we did it. So let me just write it into the form that we're used to seeing. So negative b plus or minus square root of b squared minus 4ac all over 2a. So there's how you derive the quadratic formula. Most likely, it's not something that we're going to ask for at the grade 10 level, but it is something moving forward in grade 11. You could be asked to prove this result by completing the square. So there it is for you. In this next problem, we're going to solve these quadratics by finding the roots. Okay. Now, roots are simply the solution to this equation. And I'm going to do these without expanding. You'll notice that the left side appears to be a quadratic in vertex form. For each of these, we could expand. And then use quadratic formula. However, what I'm going to do is I'm going to leverage the fact that it's in a form I like. So we've got 1/2 x minus 2 all squared minus 5 equals 13. I can bring that 5 to the other side and change it to positive 18. And now let's deal with this 1/2. I'm going to multiply both sides by 2. And I'll get 36 on the right-hand side. We have to undo the squared, which is the square root. Now, one of the things to keep in mind is that it's going to be plus or minus square root of 36. So x minus 2 is equal to plus or minus 6. So x is going to be 2 plus or minus 6. Two possible solutions, either x is 2 plus 6 or x is 2 minus 6. And we would get x is 8, or, of course, x is negative 4. And hopefully that works out well for you. And question B, again, is very similar to the first one. We're going to start by, we'll bring this guy, this negative 0.18 to the other side. So we'll have 0.02 x minus 1.47 all squared is equal to positive 0.18. We'll eliminate this 0.02 by dividing both sides by the number out front of those brackets. Remember, when you solve an equation, you want to use your Bedmas rules in reverse. And so when we do that, we of course want to get rid of, let me just find a spot to scribble Bedmas. So Bedmas. We want to get rid of any subtraction or addition, any multiplication or division, any exponentiation, which would be squares or square root. We would need to square root if it's a squared. If it's a square root, we need to square it. And then last and not least, we get rid of brackets. So we're always going in this direction when we're solving for an unknown. I believe when we do 0.18 divided by 0.02, we get 9. So now at this point, we're going to square root both sides, and we're going to get plus or minus square root of 9, which we all know is simply plus or minus 3, which gives us x is 1.47 plus or minus 3. And we can separate that as 1.47 plus 3, or our other solution is x is equal to 1.47 minus 3. So we get 4.47, or I believe negative 1.47. 5.3. And last and not least, this last one here, we can do exactly the same thing. So x plus 1 all squared is equal to negative 125. We'll divide both sides by 5. And 125 divided by 5 is negative 125 divided by 5 is negative 25. And now when we go to find the square root of this one, we're going to get plus or minus square root of negative 25, which has no solution. And because we cannot square root a negative over here. Square root of negative 25. Square root of 25 is 5, but the square root of negative 25, it has no real solution. So we're stuck. And so there is no answer to this. And if you take a look at what the original question is actually stated as, this appears to be a quadratic with vertex 1 and 125. Graphically, that would look something like this. There's your vertex, and it opens upwards. So it doesn't surprise me that the quadratic is never equal to 0, which is what algebraically we were able to show. So that leads us to the second word problem here, where we deal with a word problem. But let's just take a momentary pause, and I'll give you a chance to read through the problem. Okay, in this second problem here, we have the path of a toy rocket is described by this equation. H is equal to negative 0.2 x squared plus 8.8x plus 16.2, where h is the height in meters and x is the horizontal distance in meters. We're asked a couple of questions here. The nice thing about this problem is it mixes together absolutely everything we've studied with quadratics so far. We're going to have to start by finding the maximum height and when it occurs, and the initial height, and then, of course, when does it hit the ground? So here we're going to have to find the zeros. So we all know that our quadratic, and then of course in step E we're asked to sketch this, but we all know that the quadratic is going to follow this sort of path. We're not quite sure what its initial height is going to be, but just yet, but it's going to follow this parabolic arc here. So let's take a look at what we can do with this. We'll start with question A, where essentially we're after the maximum height and when it occurs. This should remind you of the vertex. That's what we need. So I'm going to find the axis of symmetry using my favorite method, which is negative b over 2a. And in this particular question, it's going to be negative 8.8 over 2 times negative 0.2. When you do that arithmetic, you will get x is equal to 22. So your axis of symmetry is 22. Now we're going to sub that into our original equation. So x equals 22 into h. So we have h is equal to negative 0.2 times 22 squared plus 8.8 times 22 plus 16.2. And you can just feed that to your calculator, and eventually you will get 113 meters. So my vertex is 22, 113. So the maximum height is 113 meters, and it occurs 22 meters after it is launched, or after the rocket is launched. After the rocket is launched. Question B, from what height was the rocket launched? So here we want the initial height. Okay, so this happens when x is equal to 0. So we're going to sub x equals 0 into h is equal to negative 0.2 x squared plus 8.8x plus 16.2. And as soon as you substitute in x equals 0, you should notice that everything will zero out except that 16.2. So that is your initial height, 16.2 meters. So 16.2 meters is the initial height. Okay. Question number C asks us, how far did the rocket fly before hitting the ground? So here we essentially need to find, or we need to solve for x when x negative 0.2x squared plus 8.8x plus 16.2 is equal to 0. Now, I don't like dealing with negative values of a. I know I probably included that in the notes that you could deal with it that way, but I like dealing with positive values of a. So I'm going to bring all the terms to the right side, or just multiply each term by -1, thereby changing the sign. So 0.2x squared minus 8.8x minus 16.2. And we're going to solve using the quadratic formula. That's the only way to find the roots for something like this. It's going to be a bit of a mess to try and factor this. I don't think it's factorable. In fact, I'm almost positive it's not factorable. Remember that the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So in my case, I'm going to have x is going to be negative 8.8, which is going to become positive 8.8, plus or minus square root of negative 8.8 squared minus 4 times a, which is 0.2, times c, which is negative 16.2, all over 2 times 0.2. If I do this correctly, inside this radical, or radicand, will work out to 90.4. Make sure when you do this on your calculator, you put this negative 8.8 in brackets when you square it. Otherwise, you're going to end up with some wonky things happening with your calculator. And this, of course, is all over 0.4. So when we work that out, we're going to get one of two solutions. X is 8.8 plus root 90.4 over 0.4, which is going to give us 45.77. And the other alternate answer is 8.8 minus root 90.4 all over 0.4, which is going to give us negative 1.77. Now, I do want to caution you, when you do a calculation like this with your calculator, make sure you put brackets around that. It's very important. For example, if you, on your calculator, you do 5 plus 10 divided by 2, and you type this in on your calculator, guess what? You're going to get an answer of 10. Because what your calculator is going to do is it's going to do the 10 divided by 2 first to get an answer of 5, and then add it to the 5. When in reality, what you actually want, there's implied brackets here. This operation in the numerator is to be done first. 5 plus 10 is 15 divided by 2 is 7.5. Very different results. So make sure that you put brackets around this and then divide by 0.4. Normally what I do when I work a question out like this is I just work out the numerator, 8.8 plus root 90.4, press equals, then I just write divided by 0.4. and then it'll do the last answer divided by 4.4. I'm very interested in what would happen if I added these two roots. So why don't you add those two roots and then divide by 2. And you should get the axis of symmetry. That shouldn't surprise you because remember, the axis of symmetry is equidistant between partner points, right? And these two roots are partner points. Now, this one over here is not valid. The reason why this one isn't valid is because when we draw our sketch, which we're eventually going to do, we have over here that this is 22, and it reaches a maximum height of 113 meters. To be honest, I like drawing the quadratic first and then fitting the rest of the graph around it. Well, let's start over. That was a bit of a disaster there. So as I was saying, I like to draw the quadratic first and then fit the points around it. So over here now, I'm going to say, okay, this is 22. This is 113. Where on earth did those come from? That came from right there, my vertex. And then, of course, over here, this is 45.77. Okay, and this is 16.2. Do you notice that I am not drawing this to scale? So this is the height, m in meters, and this is the distance, x in meters as well. There's one other part that I need to do here is what was the rocket's height when it was 5 meters from the launch point? So question D, of course, is to find h when x is 5. So we have simply to make this substitution, and this seems like a good job for a calculator. And when you put that all in on your calculator, you should get 55.2 meters. So over here, not going too crazy trying to draw it to scale. Boom. That corresponds to 55.2. Keep in mind, this is just a rough sketch. There should be a partner point over here. And it's also got a y coordinate of 55.2. The question, of course, is what's its x coordinate? So think that through for a minute, and I'll give you a clue. This right here is our vertex. The axis of symmetry is right here. And what's the distance here from this point to the axis of symmetry? And the other one should be equidistant on the other side. And I think that that's 17 units. No, maybe not 17. Is 17 too many? 17 seems about right. So the other one would be 17 in the other direction, which should be 39. So convince yourself of that. Hopefully you're okay with that. One other thing I wanted to talk about, since I've got your attention here, is taking a look at the domain and range of a question like this. I would say that our domain, remember in the last unit we guessed on the domain when it hit the ground. Well, now we know with some certainty that it's 45.77. And we didn't know that in the last unit. And our range, of course, is y is an element of the reals. And it's between 0 and, it's actually not going to be y, it's going to be h, because that's our variable. I'm going to have to fix that over there. And I believe it goes to 113 meters. And that should be that. Hopefully that helps. Good luck with this. And I will post a few other videos when I get to it.